section 2.14, you're learning about slope. And there's several ways that the problems are presented to you. So I'm going to go ahead and go over a couple of examples from this section. And the first one, you're given a graph, and they want you to find the slope of the line shown in the graph. So there's two ways that you could do this. The simplest way, I think, is to actually look at the graph, and if you remember, how do we define slope? Slope is defined as rise, change in y, over run. So rise in this graph, I can go ahead and go from this point to this point, and I'm talking about the change in the y. So what do I have? 1, 2, 3, 4, 5. It's gone up 5, so it's plus 5. And then the run is the change in the x. 1, 2, 3, 4, 5, 6. So the slope of this line is 5, 6. Now another way I could work this problem is to find the coordinates of the 2 points. And let's call this one point 1 and this one point 2. And let's write down the coordinates. So for point 1, which I'm going to call the x1, y1 point, the coordinates are -2 and -4. So remember, to find the coordinates of the point, we start at the origin, we move horizontally first and then vertically. And then my second point, which will be x2, y2 in my slope formula, the coordinates here are 1, 2, 3, 4, and then I go up 1. And then remember, slope can also be calculated as y2 minus y1 over x2 minus x1. So y2, so I've got 1 minus -4, and then x2, 4 minus -2, and what do I get? 5 over 6, which is the same answer that I got using the direct inspection of the graph. All right, let's try another kind of problem you're going to see in this section. Here you're given a table of points, x and y coordinates, and they want you to find the rate of change. And again, remember, slope is rate of change, and we can write this down as change in y over the change in x. So let's take a look. Let's do the x first. Let's see what's going on with x here. It's going up each time by 1 unit. And now how about y? So to go from 11 to 9, we go down by 2 units. 9 to 7, 2 units negative. So the slope here is -2. Let's do another one with a table with a little bit different information. This time you're given the table and you're told the slope, and you're only given one xy point filled in. They want you to find the rest of the points. So let's take a look. So if you notice here, again, remember, slope is change in y over change in x. Those little triangles mean change. Now, if I notice here, it's telling me it is 1 over 4. Okay, so in every case, x is going to go up by 4, right? 4, so -4 plus 4 gives me 0, plus 4 gives me 4, and 8. Y is only going to change by 1 unit, so I can fill in the rest of the table here. 3 plus 1 is 4, 4 plus 1 is 5, and 5 plus 1 is 6. All right, one last problem, an application problem. Find the slope of the line, and then they also in the problem want you to interpret in the context of the problem. So here we're talking about the cost to own and operate a truck. So let's call this point 2 and this point 1. And remember my slope, y2 minus y1 over x2 minus x1. This is a little bit harder to read directly off the table, so I'm going to use the formula. So y2 here is 18,900 minus 9660, change in y, and then over the change in x, 45,000 minus 23,000. All right, so what do I get? In my numerator, I'm going to get 9,240 divided by 22,000. That's positive. And if I go ahead and I divide that, I get 0.42. What this is telling me is this is the cost in dollars per mile driven. So for every mile I drive my truck, it costs me 42 cents in context. It's important to interpret problems in context. It makes a little bit more sense than just saying the slope of the line is 42 cents. So hopefully this will help you as you're working through problems in section 2.14.